Today we're doing lesson 7.5 on factoring special products. In this lesson we are going to factor a perfect square trinomials, and then we'll factor the difference of two squares. So previously we studied the patterns of some special products of binomials. You can use these patterns to factor certain binomials. A trinomial is a perfect square if the first and last terms are perfect squares. The middle term is 2 times one factor from the first term and one factor from the last term. So 9x squared is a perfect square. 9 is 3 times 3, and x squared is x times x. And then our last term, 4, is a perfect square. It's 2 times 2. Then to check if our middle term meets the requirement of being 2 times one factor of the first term and one factor from the last term, we're going to take 3x times 2, because 3x is one factor of the first term, 2 is one factor from the last term. So 3x times 2 will give us 6x, and then we take that and multiply by 2. So 2 times 6x gives us 12x. So therefore, this trinomial is a perfect square. So there's two different cases of perfect squares. One where we're going to have positive values, a plus b times a plus b, and then we'll have a minus b times a minus b. And here the only difference is that this middle term is positive when everything's positive, and then the second one, the middle term's negative. So that's going to make our b terms in our binomials negative. So we're going to go ahead and look at example 1. Okay, for example 1, we are recognizing and factoring perfect square trinomials. So we're going to determine whether each trinomial is a perfect square. If so, we'll factor. And then if it is not a perfect square, then we just need to explain. So x squared plus 12x plus 36, that is our first example. X squared can be broken into x times x, and 36 can be broken into 6 times 6. So then our middle term, we need to check if x times 6, so x times 6, and then we multiply that by 2. So x times 6 is 6x times 2. That will give us 12x, which is exactly what we have here. So this means this can be factored to x plus 6 times the quantity x plus 6. And we can also rewrite this using an exponent. You can say x plus 6 quantity squared. B, we have 4x squared minus 12x plus 3. So 4x squared can be written as 2x times 2x. And then for the 9, 9 can be written as 3 times 3. So then for the middle term, we're going to take 2x, multiply that by 3, and then times that by 2 to see if we get 12x. 2x times 3 is 6x times 2 gives us 12x. But this time, it's going to be negative. So we have to write this 9 as negative 3 times negative 3. So this is going to become 2x minus 3 times the quantity 2x minus 3. And then again, you can rewrite this using an exponent. So 2x minus 3 squared. For C, we have x squared plus 9x plus 16. X can be rewritten as x times x, and 16 can be rewritten as 4 times 4. For this middle term, we're going to have x times 4 and times that by 2. X times 4 is 4x, times 2 gives us 8x. We want 9x. 8x does not equal 9x. So therefore, this is not a perfect square. So that is how you do example 1. So now there are 3 check it out problems for you to do. You're going to determine whether each trinomial is a perfect square. If so, factor. If not, explain. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So x breaks down to x times x, and 4 breaks down to 2 times 2. X times 2 will give us 4x, which is exactly what we want. So we're going to rewrite this as x plus 2 times the quantity x plus 2, or you can rewrite it using an exponent, x plus 2 quantity squared. For b, x squared can be rewritten as x times x, 49, 7 times 7. And then we have x times 7 times 2. That'll give us 14x. And this is a negative 14x, so when we rewrite this, this 7 will be a negative 7 times a negative 7. So this is going to be x minus 7 times x minus 7, or you can rewrite it as x minus 7 quantity squared. For c, you can rewrite 9x squared as 3x times 3x, and 4 as 2 times 2. And then we're going to have 3x times 2 quantity, take that quantity, multiply by 2. 3x times 2 gives us 6x times 2, 12x. And we want a negative 6x, so 12x does not equal 6x here, so this is not a perfect square. So that is how you solve those check it out problems. So now we're going to go ahead and look at example 2. For example 2, we have a problem-solving application. It says the park in the center of the Place des Vosges in Paris, I'm not sure if that's how you pronounce it, but in Paris, France, is in the shape of a square. Okay, so here in our picture we can see it's a square. The area of the park is 25x squared plus 70x plus 49 feet squared. The side length of the park is in the form cx plus d, where c and d are whole numbers. Find an expression in the terms of x for the perimeter of the park. Find the perimeter when x equals 8. Okay, so here we are going to factor this trinomial, and then we'll go back and substitute in 8 for x to go ahead and find that area. So remember, a square, both sides are the same length, so this is going to have to be a perfect square. So looking at our trinomial, we're going to go ahead and factor it. So 25x squared is 5x times 5x, or 5x squared. And then 49 is 7 times 7, or 7 squared. And then remember, our middle term is 5x times 7 times 2. So 5x times 7 is going to be 35x times 2 gives us 70x. So 5x squared is 25x squared. And then our middle term, 70x and 49. So we can rewrite that as 5x plus 7 times the quantity 5x plus 7. Or, if you want to use an exponent, 5x plus 7 squared. Okay? And then from here, we are going to find the perimeter. Remember, perimeter is the distance around the outside. And there's 4 sides of our square that are the same. So 4 times our side length are 4 times 5x plus 7. Now you can use this equation right here, or this expression I should say, to substitute in the length of 8, or you can distribute this 4. So 4 times 5x is 20x, 4 times 7, 28. Then from there, you're going to evaluate the expression for x equals 8. So for x, you're substituting in 8. So 20 times 8 plus 28 gives us 188. So it means the perimeter of the park is 188 feet. So that is how you would solve that example. So now there is a check it out problem for you to do. So it says, what if a company produces square sheets of aluminum, each of which has an area of 9x squared plus 6x plus 1 meters squared. The side length of each sheet is in the form cx plus d, where c and d are whole numbers. Find an expression in terms of x for the perimeter of a sheet. Find the perimeter when x equals 3. So first we're going to do, we're going to take this trinomial, 9x squared plus 6x plus 1, and factor it. And then we'll substitute in 3 for x to find the perimeter. Remember, perimeter is 4 times the side length. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So 9x squared would be 3x times 3x. 1 is 1 times 1. And then our middle term would be 3x times 1, and multiply that by 2. And just to check, 3x times 1 is 3x times 2 gives us 6x. So that is our middle term. So to factor this, this would be 3x plus 1 times the quantity 3x plus 1. Or you could rewrite this as 3x plus 1 quantity squared. Now to go find the perimeter, remember perimeter equals 4 times the side length, and in this case our side length is 3x plus 1. So you can distribute that 4 if you want. So 4 times 3 is 12x, and then plus 4 times 1 is 4. Then we're going to evaluate this for when x equals 3. So we're going to have 12 times 3 plus 4. 12 times 3 gives us 36, and then 36 plus 4 gives us 40. So the perimeter is 40, and then our label would be meters. So 40 meters. So previously you have learned the difference of two squares in the form of a squared minus b squared. The difference of two squares can be written as the product of a plus b times the quantity a minus b. You can use this pattern to factor some polynomials. A polynomial is a difference of two squares if there are two terms, one subtracted from the other. Both terms are perfect squares. So here 4x squared is 2x times 2x, and then 9 is 3 times 3. So we have two terms here. The first term and the second term are both perfect squares. So when we have two perfect squares, we can rewrite this as a difference of two squares, where I had the a plus b times the quantity a minus b. So this you would rewrite as 2x plus 3 times the quantity 2x minus 3. So you're taking your first term, second term, and then you have an addition sign and a subtraction sign. So in example 3, we are going to recognize and factor the difference of two squares. So determine whether each binomial is a difference of two squares. If so, factor. If not, explain. So for a, x squared can be x times x, and 81 is 9 times 9. We have two terms, both are perfect squares, so we can rewrite this as x plus 9 times the quantity x minus 9. Second example, b, we have 9p to the fourth minus 16q squared. So 9p to the fourth can be rewritten as 9p squared, 3p squared times 3p squared, because 3 times 3 is 9. P squared times p squared gives us p to the fourth. And then 16q to the fourth can be rewritten as 4q times 4q. I have two terms, both are perfect squares, so I can write them as a difference of two perfect squares. So 3p squared plus 4q times the quantity 3p squared minus 4q. And then our last example, C, we have x to the 6th power minus 7y squared. X to the 6th can be written as x to the 3rd times x to the 3rd. And then this 7y squared, 7 is not a perfect square. I could do y times y, but this 7 is not a perfect square. So for this example, I cannot rewrite this as a difference of two squares. 7y squared is not a perfect square. So it cannot be written as a difference of two squares. So again, both terms, the first and the second term, have to be perfect squares. If the first one is, second one isn't, then you can't rewrite it. So now there are 3 check it out problems for you to do. Determine whether the binomial is the difference of two squares. If so, factor. If not, explain. So take a moment, pause the video, and then resume when you're ready to check your answer. So 1 can be rewritten as 1 times 1, and then 4x squared can be 2x times 2x. So this can be rewritten as a difference of two squares. So 1 plus 2x times the quantity 1 minus 2x. And I don't think I mentioned it yet in this video, but you can change the order that you're writing this. So the 1 minus 2x could come first, or the 1 plus 2x could come second. So that is another way that you could rewrite that as well. So p to the 8th can be p to the 4th times p to the 4th. And then 49q to the 6th can be 7q to the 3rd times 7q to the 3rd. So this can be rewritten. So p to the 4th plus 7q to the 3rd times p to the 4th minus 7q to the 3rd. Last one, 16x squared can be rewritten as 4x times 4x. And then y to the 5th is not a perfect square. So this one cannot be written as a difference of perfect squares. So that is how you solve those check it out problems.